Modern manufacturing plants generate millions of data points every single second, capturing the precise heartbeat of every operating machine on the production floor. To handle this flow, facilities have spent decades investing heavily in dense sensor networks, OPC UA protocols, and massive historian databases. Yet, despite sitting on terabytes of operational intelligence, most plant managers cannot get an immediate, specific answer to a basic production question. This chart explains why. SCADA and HMI screens are built exclusively for real-time process monitoring and predefined control actions. They are not designed for ad hoc investigation. When an unexpected event occurs, finding answers means bypassing dashboards entirely and digging directly into raw historian tags. That manual extraction process requires a specialized engineer who understands the complex, cryptic tag structures of the database. This creates a structural flaw in the operation, known as the UI bottleneck. The data exists, but the time required to format it delays time to insight. Operational data that cannot answer a direct question before the window of action closes is no longer an asset. It is an archive. We are going to map the architecture of this specific latency trap and look at the exact translation layer required to bypass it. Solving this query barrier converts a plant's existing data infrastructure into a realized financial asset without requiring new hardware. Consider a common high-stakes scenario. At 2 a.m., a critical production line experiences an unplanned downtime event. In the immediate aftermath, the operators in the control room are hit with dozens of simultaneous alarm cascades. Finding a clear root cause in real time is nearly impossible. Look at this shift timeline. The trip happens at hour 2, but manual investigation drags into the morning meeting at hour 12. An engineer has to pull tags, configure time windows, correlate alarm logs, and separate the originating failure from downstream symptoms. By the time the root cause is isolated, the night shift operators have gone home. The context is cold. Without immediate corrective action, the same failure mode will likely repeat. This latency causes direct, measurable damage to a facility's overall equipment effectiveness, or OEE. This chart highlights the discrepancy between the average plant running at 65% OEE and the world-class target of 85%. That 20% efficiency gap is largely composed of invisible micro-stoppages, disruptions lasting less than 5 minutes each. Because manually investigating a 5-minute stoppage takes hours of engineering time, these minor losses are never recorded in shift reports and never systematically fixed. Systemic OEE underperformance is rarely an equipment failure. It is a direct symptom of investigative latency. This lack of access extends beyond past failures and cripples the ability to predict future ones. Production availability is driven by mean time between failure and mean time to repair. Improving these metrics requires catching assets before they break. Determining if a specific asset is drifting from its 30-day baseline requires comparing current historian trends against past failure patterns. That requires highly labor-intensive manual data extraction. Without fast query capabilities, maintenance schedules remain entirely reactive. Teams wait for an alarm to trigger rather than catching the deviation early. To survive this lack of data accessibility, the industry relies on a workaround known as tribal knowledge. Relying on a 30-year veteran's mental map of alarm patterns becomes a critical operational liability the moment that individual retires or simply goes off shift. This vulnerability peaks during the highest risk moment in daily operations, the shift handover. Instead of a comprehensive data review, incoming operators are forced to rely on brief verbal summaries covering the last 12 hours of production. Subtle, slowly drifting baseline deviations and recurring minor alarms are almost always lost during this verbal translation. Whenever data access requires specialist mediation, a plant is forced to run on human recall and lagging indicators rather than objective historical truth. Breaking this query bottleneck requires a new architectural approach, an agentic AI translation layer. This diagram illustrates an additive intelligence layer. It sits on top of existing systems, requiring zero rip and replace. Its core function is acting as a natural language API translator for industrial protocols. It automatically identifies tags, sets time bounds, and cross-references alarm logs with baseline trends. A root cause investigation that previously consumed 10 hours of engineering time now executes in 10 seconds. This architecture solves the shift handover risk by instantly outputting a comprehensive list of every baseline deviation from the last 24 hours. And because this process can be executed locally and completely air-gapped, stringent OT cybersecurity is perfectly maintained. This agentic layer democratizes the historian. It allows any operations manager or shift lead to interrogate the plant's data directly, precisely when it matters most. Transitioning to plain language SCADA queries changes how managers interact with their own production floor. It moves a facility away from a passive cadence of reviewing losses and weekly post-mortem meetings to an active state of interrogating microstoppages the exact moment they occur. This graphic shows the concrete financial outcome. Gartner research indicates that real-time KPI visibility yields 23% higher OEE. The logic behind this metric is straightforward. Operational losses identified while the shift is still running can be stopped before they compound. The ultimate purpose of all industrial data collection is not merely to build a perfect, untouchable historical record. Data is only useful if it serves the human operator actively fighting the daily entropy of the manufacturing floor. A plant's infrastructure only achieves its true ROI when it can provide the exact answer to a specific question in the exact moment the opportunity to act still exists.